and welcome to Dr. G's Technique of the Week, Geometry Edition. Let's review how to find the volume of 4 related three-dimensional solids. We're going to start with a rectangular prism and then a rectangular pyramid with the same base. So we'll have a 4-inch by 2-inch base in each case, and also the same height as the prism. So for a rectangular prism, for any prism, remember that the volume can be found by taking the area of the base and multiplying it by the height of the prism. And for a rectangular prism in particular, this is going to be the length times the width of the base times the height of the prism. So take a moment now, find the volume of this particular rectangular prism. So to find that volume, we just multiply our length times width times height. So 4 times 2 times 6, which gives us 48. And our units of length are inches, so we keep those but make them cubic since this is a measure of volume. For a pyramid, we could imagine putting this rectangular pyramid inside of the rectangular prism and having it fill up exactly 1/3 of the inside of that rectangular prism. So the volume for any pyramid is 1/3 the volume of a prism with the same base and the same height. So 1/3 times the area of the base times the height of the pyramid. So in this particular case, since our base is a rectangle and it's 4 by 2, our rectangular base will give us length times width for the area, so 1/3 times length times width times height. So now take a moment, find the volume of this rectangular pyramid. Since we already have the volume of the rectangular prism, we can actually take a little bit of a shortcut here and do just 1/3 times 48. Rather than doing 1/3 times 4 times 2 times 6, but either one will bring you to the same end with 16 cubic inches. Now, very similar to prisms are cylinders. We can think of a cylinder really like a prism with a round base instead of a polygon base. So the volume of a cylinder is also the area of the base times the height. But in this case, since our base is a circle, we use pi r squared to find the area of that base. So we end up with the more familiar volume formula for a cylinder, which is pi r squared times h. So given our radius of 3 meters and our height of 8 meters, go ahead and find that volume now. All right, so just plugging in the values that we have for radius and height, we'll have pi times 3 squared times 8. 3 squared is 9 times 8 is 72, so this is 72 pi. And then if for a particular problem, we need to find an approximation for that value, because maybe this is an applied problem and we want to say something about the number of cubic meters of space that are in here in a way that is easier to imagine the quantity for. A good approximation for pi is 3.14. You can do 72 times 3.14 to get an approximation for this, or about 226.08 cubic meters. Now for a cone has the same relationship to a cylinder as a pyramid does to a prism. We have the same base as our cylinder, but everything raises up to one apex, one vertex at the top. So our cone volume is 1/3 of its corresponding cylinder's volume. In other words, 1/3 the area of the base times the height, or since our base is a circle, 1/3 pi r squared h. So using that, go ahead and find the volume of this particular cone now. Again, we can take a little bit of a shortcut since we already found that pi r squared h was about 226.08. We can just immediately say that this is going to be about 1/3 times 226.08 and calculate that that is 75.36, and again, meters cubed. Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.